everyone, welcome to the concrete structure tutorial using S3D. I'm Daniel Vivas, Product Manager of SkyCiv Engineering, and in this tutorial I'll guide you through the process of modeling, analyzing, and designing a concrete structure using S3D. Remember that you can find more information about concrete structures and many more topics in our documentation. So let's get started. We will create a new project. We will start by creating all of our members. In this case, I won't use this form. I will use the pen tool. I can activate it here and I will start. The first member will have 5 meters. The second one will have 8 meters. I will close it here. The next one will have 10.5 meters. Now I will replicate my structure. So I will hit Ctrl A, Ctrl C. I can select this node from reference. Then I will select this one and I will hit Ctrl V. I'll select this node again and hit Ctrl V again. Now I will replicate this structure in the Z direction, so I will hit Ctrl A. I can go here to Edit Operations, Repeat, or just hit Ctrl D. I'll select Rotation. This angle will be 90, and that's it. I'll click Submit, and I'll have my structure here. I'm gonna copy all of these structures just to finish my building. I will create some materials and sections for my structure. In this case, I can use these forms to create them, but actually I will use this section builder that is a SkyCiv product. In this case, I will use rectangular columns, so I will modify this dimension to 600, and I can modify the material right here. I will select concrete, and that's it. I will submit my section. By default, all of the members that were unassigned will use this new section that I just created, but for the beams I will use another section, so I will just proceed to create it. It will have 500 millimeters by 700 millimeters. Now I will assign this section 2 to all my beams. So I just have to select them. Then I will go to members. All of them are selected, all of my beams. So I can select here the section ID that I want to use. In this case will be this one, and I can hit on apply. You can see now that all my beams and columns have the correct sections. Let's create now walls for our structure. We can assume that we have an elevator here. So what we can do is that we will use plates to model all the walls. So we just have to select these nodes. I'll do right click and add plate. And you can see that my wall is created. So I will use the same process for all of these remaining walls. To create these slabs, I will use this plates button. I can type all of my node IDs. For example, I can type 2992, but actually you can just click on the nodes where you want to create your plate. In this case, I think is, no, finish here, 27. And you can define here the plate thickness and the materiality. I will leave it like this. And I will use the same process to create the remaining slabs. In this step, I will create plate holes on all these slabs. So actually I will see the hole of this elevator. So the first thing that I will do is hide all the members. I can do it here. Also, if I zoom in, you can see that we have these node IDs 69, 85, 82, and 66. So I will select this plate. I'll do right click, plate hole, and I'll enter those node IDs that I just see here, 69, 85, 82, and 66. I'll hit on submit, and that's it. You can see that there is a new hole on this slab. So I'll do the same with the remaining slabs. In this step, I will show you how to create mesh plates. For this example, I will hide these nodes so you can see it better. You have to select all of your plates. You can hit Ctrl A, do right click, and select mesh plates. Here you can choose a type of element to use. In this case, we will use unstructured quadrilaterals. The meshing method, so you can modify it, the granularity of your meshes. If you want a physical size for your meshes, you can type it here. Also, this will include all these nodes and members. It detects what nodes and what members we are touching with our plates. And this is very important to leave this checked, so it will include other plate edges. So our walls and our slabs will be connected. So I will leave it like this and I will click on mesh. Now I can see that all of my meshes are created in the walls and also in the slabs. Now I will show all the members again. I will hide the plate mesh and also the plate mesh nodes. So when I activate these nodes, actually I will hide also the plates because I'm gonna apply some load, so it's easier to have the model just like this. I will create now the area loads. So in this case, I will leave it as one way. We will assume that only the beams in this direction will take all the load. So I can type here the core node IDs. In this case, I will just select these external nodes. The pressure magnitude will be -5 kilopascals along the y-axis, and the beam direction, as I said, it will be this direction. So we can type from node 2 to node 9, and the program will detect that that will be the direction. So 9, and I will leave this load group just like this, and I'll click on apply. You will see that our load is created, so I can actually go to visibility settings and I'll click here on equivalent area loads, and you will see that our area load is created properly. So I will repeat the same process for these floors. After the creation of our area loads, we will activate the self weight. So actually all of our members and our plates will have self weight. So we have to ensure that this is on, that our value here is -1 along the y-axis, and we just can click on apply. Remember that this load group will be named SW1. Hit on apply, and that's it. Let's create now our supports. In this case, I will select all of my floor nodes. I'll go here to supports. I'll double click in this field. The program will identify which nodes are selected, and I will use fixed support. I'll click on apply, and that's it. Now I will create the load combinations. I will select here the design codes. I will choose the ACI here on display. You can see the load combinations, and we can verify here that our load group, this corresponds to a live load. It's a live load in the design code, and that the self weight corresponds to a dead load, so this is correct. You have to be careful because sometimes this could appear like this, so this is wrong. So you have to ensure that your loads correspond to the ones in the design code. So I will choose this and I'll hit on import. You can see that our load combinations are created properly, so we will go back and that's it. Now that our model is finished, I will show again all the plates and also the plate mesh. So you will see all the structure finished, and we can go to the solve section and we will use the linear static. Now let's check the results. We can choose here what load combinations to see. In this case, I will use these envelope max for this example. We can see here the reactions, the share results. I can modify this scale so it is better. You can see the moments, the actual values. You can see also the displacement of each node. For plates, I will actually activate them. We can choose one result to see. In this example, I'll choose the moment. You can see all the results here. You can select one of these results. For example, the displacement. You can see here the values. Also, you can check if you want to see the results for a specific mesh. You can just put your mouse above of it and you will see the results. Also, you can use something called section codes, where you can define a load combination, and start node and an end node, and it will show you the results for that cut. We can create reports. You can select what loads combination to see. I'll just choose this envelope max. I will actually just select the plate results. You can also select this member, but let's just leave it like this. So these displacements. I'll create the report. It will take a couple of seconds to generate it, and once it is done, it will show me the report. Now that our report is generated, you can see my plate results and see all these forces for each mesh plate. You can just check the values for all the slabs and walls, and I can actually download this as a PDF or as a HTML file. Let's now design our structure. I can go here to Design, Start New Code. I will select RC Member Design, and I will choose the ACI Design code. I'll click on Start. And this will open the RC Design module. In this design module, I can see all the members information, also the forces combinations. I will click here on members. I can modify the members parameters. I can modify these effective length factors, also the deflection coefficient. I'll leave it like this. I can also modify all the reinforcement layouts, in this case for my beams. I will click here. You can see that by default we just have one river layer. I will add two more. I will say that this one will be 5 inches from the bottom. You can see that it now appears, and that this will be at the top of my section. You can see now all the rebars appearing in my section. I will actually find this as 4 bars, and I'll leave it like this. I will click on save and go back, and after I have all my members checked, I will click here on check. This will calculate all the design checks for all of my members. We can see here that we are having trouble with our sections, so we can go to this report, for example, and we can see what's going on with our design check. We have a problem with our moment resistance that is lower than the moment applied. So we can also check here that the bar spacing is lower than the one permitted in the design code. So we can go to our model again and modify the sections, or come here again to the members and modify the layouts, but I will use this optimizer. So I will click here. I can define some values here. You can see it in the image. I will leave it just like this, and I will run the optimization. Now that it has finished, I can see that all my status is okay. So I can see the report to see the layers of my reinforcement. For example, now the optimizer put these new layers, and I can see that all of my calculations are passing. So this is another way to design your structure instead of making a manual process and going back to your model. You can also use this optimizer. Now let's go back and we will start designing all of our plates, our slabs and our walls. Let's click here on Start New Code. We'll select RC Plate Design, and we will choose the ACI standard. Here you can define some information about your project. In structural element, we can define the structural type. In this case, we will leave this slab. The arrangement, you can define these values. You can actually see the information about this if you want to modify this angle alpha, beta, and also this limit of crack widths. This optimizer, here we can define what values to use when we are using the optimizer. So you actually can modify these values. These materials and factors, you can modify the concrete grade, the reverse grade. Also, if you want, you can modify these values just by clicking here. on change, and you can also modify these values of tension, compression, and shear and torsion. The load combinations will be the loads that we are going to use for all the designs. In this case, I will use this as a strength check and this as a serviceability check. You have to ensure that this is well defined. Just for this example, I'll leave it like this. And in the river, we can assign reinforcement data manually, and also we can use the optimization results. Now, the first thing that I'm going to do is go back to structural element. Here, I can select what element I'm going to design. For example, let's choose this element. I will click on add, and you will see that a new element is listed here. So I can go back to the river and I will choose the assign reinforcement data based on optimization results. You can also use this data manually, but in this example we will use these optimization results. I have to select my element. I can do it just by clicking in the ID. I will click on it, and you can see that this is now in an orange color. So I'll click here. Here I can see how much reinforcement we need for our plate. In this case, we don't need reinforcement, but in the standard it is defined that we need at least reinforcement in our slabs, so we have to actually add some reinforcement to our slab. Here we have a really cool feature, that is that you can define bar sizes or spacing, and based on these values the program will tell us what to use. So for example, if I define this spacing of 200, I can select all my plate. I can click here on display sizes, and it will tell me that using this spacing of 200 I have to use this number 10 rebars. And if I do the opposite, if I have the bar size, I can select all my plate and I can click here on display spacing, and it will tell us that we need a spacing of 400 millimeters using this bar size. In this case, I will use a number 10. I will select the whole slab and I will add and recalc. So I will click on this button. You can see that a new item is added into this list of rebar. So I can go back, and after I have my slab, I can click on it again and I can click on perform check. So it will run all the design checks and it will tell us if our plate is passing or not. So you can see here this direction 1 top. This is actually the direction where we just added the reinforcement. So you can see that these values are really close to 1, but if our ratio is less than 1, it will pass. If it's higher than 1, it doesn't pass. So we need to check this again. If I check the other results, this is under 1, so it is okay. If I check this direction on the top, you can see that we have very high values. So the reason is that we didn't add any reinforcement in this direction, so that is the reason. And if we check this tier 2 button, you can see that also the values are very high. So we can repeat the same process. We can go back and add more reinforcement in these directions, and that's it. That's how we can design our slabs. You have completed the concrete structure tutorial using S3D. I hope this tutorial has provided you with valuable insights into the process of modeling, analyzing, and designing a concrete structure using S3D. If you have any questions or need assistance,